My talk is on what was short time ago Entity Framework 7, but has now been renamed EF Core, or Entity Framework Core 1.0, mainly to keep in sync with the new .NET Core stuff that's coming out. So there's often been a name change, and through the history, you'll see in a minute the history of Entity Framework, they've changed the name to match the name of something else, and that's what's happening here. So what I'm going to talk about. The first thing I'm going to talk about is a little bit of the history of ORM in the C# space and the future of .NET Core. What's the current state we're in, which is bringing these items forward. Then I'm going to talk about the DbContext, which really is the most important thing to understand if you want to learn anything about Entity Framework. And then I'm going to go into more details about things that have changed, changes to the Fluent configuration system, and changes to how you run Entity Framework migrations. I'm then going to go over dependency injection, which is now very important to Entity Framework, and how to manage your DbContext lifecycle. I'm finally going to finish with a few slides and a bit of a talk about onion architecture and repository patterns, knowing full well that not long ago I gave a whole talk on onion architecture, so I'm going to keep that fairly short and just focus on Entity Framework 7 and what's changed. I'll show some slides of where you can find more information a little later. This is me, Brendan Richards. That's a photo taken earlier today, so it's quite a good photo now. For some weird quirk in my career, I was working with object-oriented code before I was working with databases. And because of that, I actually think in objects more than I think in databases, which is, I've noticed there are really two types of people that I work with. Some people are database first, some people are object first. And you ask someone to design a program, the object first person will think, well, what objects and entities do I need to model this structure? The database first person will think, well, what tables do I need? This makes quite a big difference when you talk about something like Entity Framework, and particularly with the whole code first versus database first debate. The database first people have been naturally drawn to database first. The code first people think code first is the way to go. I've been using various ORMs for quite a while. I've been working before I was in .NET, I was working in the Java world, so I had more options there. And I've used a fair few, so that's sort of why I'm kind of giving this talk, is having used a few different ones, I understand a little bit more about what the differences between them are. And if you ever have a chance to phone SSW for any reason and you hear kind of awful noise of clattering and battering in the background, that would be me hitting my keyboard. So going back to the history of .NET and ORMs, we'll start with 2002 with the very first release of .NET and ADO.NET. Now what came out with ADO.NET was a kind of object-oriented way of talking to your database. But what that meant was that you had a table record, you had a row record, you had a data set. So it wasn't really involved with modeling the things in your database, it was more creating objects that you then use to talk to the structures that were already in your database. Around about the same time that .NET was starting to take off, the Java world had a few things happening. There was a couple of ORMs were starting to come into practice. What people were doing at the time was something called N-tier architecture, which generally meant you had a database, you had some kind of data access layer that would create entities and sort itself out, getting things to and from the database, and then n number of layers between you and the web application. Then around this time, a couple of products came out. The first one I worked with was something called OJB, which stands for Object Relational Bridge. Then Hibernate started to come out, and also there was a few very expensive rapid application tools where you could draw boxes with lines between them, hit a button, and it would generate a whole bunch of classes that would load itself to and from the database. Later on in 2004, the very first beta versions of NHibernate came out. So this is really where ORM starts to take off on the .NET space. NHibernate was pretty much a class for class, not exactly, but it started off being a very close copy of Hibernate. So a lot of innovation around the time in the .NET space was just taking Java projects and porting them across to C#. And that was easy to do because C# and Java has quite a few similarities. So all the way over to 2005, we've got .NET 2, and that adds generics. And the interesting thing here is round about the same time, both Java and C# get generics very close together, and they're getting in a very similar way. Even the syntax is very similar. So they're kind of neck and neck. And when that happens, Hibernate itself adds support for this. So you've now got the ability to persist typed collections. So now in 2007, we finally get .NET 3.5. So moving from .NET, the interesting thing here is they went from .NET to all the way from 3 to 3.5 without changing the underlying core. The framework, .NET 2.0, was the same, they just added new features. And the big features that came with .NET 3.5 were link and link to SQL. So this is the first time Microsoft are really getting themselves involved in the whole concept of ORM mapping. Link to SQL was released then, and I was told on Monday at Canberra that the reason we had link to SQL and the reason we had Entity Framework is link to SQL was written by the core C# guys as one of the things they wrote, link to objects and all the different link versions they added. Link to SQL was one of the versions they added, where Entity Framework came from the data team. And so both products came out, and then it was Entity Framework that won out in the end. And while that's going on, Hibernate's picking up these changes to .NET. It's adding support for a fluent way to query your database, where previously in Hibernate it just had this kind of like an SQL text string, but one that understood objects. Now it's got a fluent API for building queries. Moving on through the history, 2008 with a Service Pack 1 for .NET 3.5. That's when the very first version of Entity Framework comes out. So now we've got a very serious contender to in Hibernate in the .NET space. Moving forward through time, 2009 is when MVC came out. That was quite a big event for me because I work mostly in web applications. And 2010, we've got quite a big update. We've got .NET 4, which introduces the whole async thing. Entity Framework 4, so we've seen some big versions coming out here. Entity Framework 4 is the second version to be released of Entity Framework, but they called it 4 to line up with .NET 4. So they're not using semantic versioning here, they're just matching up by product name. And NuGet. So a lot of the stuff we use now is based on this platform. We've got NuGet with .NET 4. It seems mad that we were working with that NuGet only 6 years ago. 2011 sees a big change because that's when code first appears in the Entity Framework space. And pretty much from then on, version 5, 2012, Dapper is released, and that's another sort of big choice to make if you want to work with an ORM in .NET. With Dapper, it's a very different beast. Both Hibernate and Entity Framework are what's called heavyweight ORMs. They do a lot of work to get information from the database, hold on to the state of that information. Dapper is very, very lightweight. You write raw SQL queries for Dapper and just convert the result of those queries into objects. And you don't have that kind of change tracking and long-term resource use. So finally, 2013 is when Entity Framework 6 came out, and pretty much there's a few new things coming in all the time, but nothing big enough to make this slide. So pretty much through the 4.1, 5 and 6, they're kind of minor point updates of the same thing. I'm going to take a moment here to talk about what an ORM actually does. So the goal of an ORM is to deal with something that's been called the object relational impedance mismatch. When you build an object model using object-oriented code, there's a whole suite of features you can use. There's encapsulation, there's private versus public methods, there's interfaces, inheritance, and polymorphism. So you can say this class is of type this class inherits an interface. In the .NET relational model, you don't really have these structures. All you have is flat tables of scalar values. So what the whole goal of object relational mapping is to provide a mapping between this rich, structured, object-oriented layer going back to a flat relational database structure. And I'd say for me, the success of an RRM can be judged on how well it can take the different constructs of object-oriented code and reliably save them to a relational model and back again. So taking a step back from that history where we've gone through how have we got to here, what's happening right now is quite a big change. A lot of things have been stopped iterating where they are. We're not getting Entity Framework 7. We're getting a whole new .NET or a whole new structure. So what does that mean? We've got this new thing called .NET Core. Has anyone got anything they want to say on what they understand .NET Core to be? Or are they excited about .NET Core? Are you scared by .NET Core? Are you looking forward to it or just dreading what the implications are?
It's supposed to be multi-platform.
That's right.
It's supposed to remove reflection and security boundaries.
Why do you say supposed to?
Doesn't yet.
That's right.
That's why.
Yeah. So there's a lot of promises, but what you're saying is that you keep dropping that supposed to because you're quite nervous about the actual. Not nervous, but yeah, it's not there yet. Yeah, so I would agree with that. It's the biggest change that .NET has ever seen. Going back to my previous slides where I said I went from version 2 to version 3.5 without changing the platform. Like code would just work on that platform, nothing would break, and they added new features. That's not what's happening here. They're taking all the bits apart, and they're pretty much rebuilding whole chunks of it from scratch. They're doing it in an interesting way, so you can still run your old stuff, and I'll show you some of that later, but there are huge changes. Eventually, this means you'll be able to run C# in more places, on phones, on non-Windows computers, in the cloud much better. It's also not quite out yet. The 1.0 release is supposed to be coming soon, but I think it'll be a fair time before 1.0 comes out and all your favourite libraries get up to speed as well. So you might have a favourite library that you use with every single project that does exactly what you want. You might find that when you try to use the new .NET Core, you're going to find your library isn't working on it yet. And you may even find that some library developers just abandon their project because they had enough. One thing that it does introduce is you don't just test your project for .NET, you've got to test your project for different versions of .NET, which I think is going to fragment the space a little bit. How they've gone about managing that fragmentation is interesting, and I think it is an improvement over the fragmentation we were getting with the kind of cut down versions, the pickle PCL libraries, things like that, where they were already making smaller versions of .NET that stuff didn't work very well on. Now they've got a centralized way of managing those different versions of .NET and getting the dependencies those versions need in place.
Brendan,
yeah.
You've done some projects and
yeah.
gone on. Did you miss any major libraries?
Yeah. First of all, there was Fluent Validation. Hasn't been updated yet to work. This is a web project, so it wasn't just .NET, it was also the new version of MVC. So I use something called Fluent Validation a lot, which is a library that has a Fluent API for specifying validation rules. What it's good for is it actually integrates with the whole pipeline that is the unobtrusive validation layer. So you have where with unobtrusive validation you could use some attributes to specify some validation rules, have those validation rules applied on server and on client side. It would still have that functionality, but you were using a Fluent API on top, and it had much more power to inject custom rules and custom kind of interdependent rules as well that would run on the server side. So you could have some simple rules running client side, much more complex rules running server side, and have it all wrapped up and into the MVC pipeline. That's the biggest one for me.
So at which point in the project did you work that out, and how much pain and what did you do when you didn't have the library?
I kind of whinged a bit and then spent a bit of time seeing if I could just hack it and make it work myself, and then gave up and went back to data annotations. So, but it was a less good option, basically. So I had to build, just go forward with less good options a number of times.
Did you try to just get the code from GitHub and recompile it?
Oh yeah, I did get hold of the Fluent Validation code from GitHub. Oh yeah, he asked me, did I get hold of the Fluent Validation code from GitHub? Yes, I did. I poked around, and I was working on a client project. I didn't have time to spend too much time messing around. I was on the clock, so I just tried something out, found it didn't work, so I had to move on. Didn't have the time on the client's clock to sit there trying to fix problems with the platform. I had to move forward with the
And
platform I
what's the
had.
vendor doing? Is the vendor updating?
I don't know. I haven't checked for a while. It might be worth looking. Do you want to go spend the time to go and
No,
look?
I was-
Yeah. Any more comments on the whole .NET Core in general? So now I'm just going to take a quick break and jump into a real .NET project and take a look at a few key points of a .NET project structure. I'm going to start with one that will give you a lot of insight, and that is actually the Entity Framework project itself. So this is the Entity Framework project, downloaded straight from GitHub. Doesn't take very long. Download it, take a look. And the key difference between a new project and an old style project is this. CS proj files are gone. They're replaced instead with this project.json. And I know there's a whole talk about all the different things they can do in .NET Core, so I'm going to just quickly run through a couple of things and point them out and then move on. So instead of a CS proj file, you've got a project.json file. It's all formatted as JSON. I'm not 100% sold on JSON files for the simple reason that you can't put comments in them. And I think that's going to be important if you're going to be... Make it bigger, sorry. Yeah, so I'm not super sold on project.json files because they can't contain comments. But a key thing to look at here, you've got a big JSON file, you've got a structure. This is kind of like your assembly info stuff. You've got, this is injecting some, well not injecting, this is fetching NuGet packages as dependencies. And right in here, you've got this construct called frameworks. So this is the frameworks that this thing can target. .NET 4.5.1 is the .NET framework in full shape that we're used to. .NET Core is the new, no, .NET Core 5.0 is the new .NET Core engine. And what's different about that is where .NET 4.5.1 would be a complete big framework that you'd have to download, I think it's like 50, 60 megabytes. This .NET Core is a very small core that then dynamically loads in the bits and pieces it needs. One of the key reasons for wanting to do this is to make it smaller. So smaller to run on a phone, or really importantly, smaller to run on Azure, where having lots and lots of servers all with a big download on them is actually costing, you know, basically it's taking up server space and generating heat and burning power. So when you move into these .NET, these framework libraries, you see they've all got slightly different sets of dependencies. So what's happening here is the things that aren't included in that particular framework by default get loaded by these configurations. And so pretty much you can run what you like under these different .NET cores, but as you use the smaller versions, you've got to start adding more dependencies into them. So with the .NET 4.5.1, you're probably not going to get any dependency problems. With the smaller ones, you're going to have to actually, okay, I've used this command over here, I need to actually make sure I've got the dependency that lets me have that. So that can be quite difficult, and what I've tend to found when we built our project, we just went with that and didn't bother with anything else, because we knew we were doing a web server, it was going to one web place, we weren't trying to run it anywhere else. So we got rid of all this stuff and just targeted 4.5.1. The other thing I want to show you is a slightly different project. The most important thing about the project.json is it no longer lists all the files that are in your project. If you ever work with source control and you've both added a file that starts with T, then you're probably going to get a source conflict because that project.json, that CS proj file has now two new lines at the same place, and you have to then merge and add both. So that gets rid of those merge conflicts on that single point of contention in your project file. The other thing I want to show you is something that's getting standard across most new style projects, is the startup.cs file. So if you've got a project that's a startup project, chances are there'll be a startup.cs file, and that builds up a few things and sets up some configuration. In this case, we're loading a JSON file, and we've got this thing here, configure services, which I'll go in much detail. So you've got this top-level dependency injection set up in startup.cs. So pretty much where most programs previously would just have either a web start, your global.asx, or where your kind of console programs didn't have much of a startup at all. Pretty much any project can be seen to have a startup.cs file, which is a central place to configure stuff up, which I think is a good standard. From the start, that's not good. Bear with me. So I showed you this briefly, that cs.project files, .cs project files have gone. We've got a new project.json structure that allows us to switch between different versions of different .NET frameworks. Moving on to Entity Framework Core, how does that fit into this new .NET Core world? Well, basically, Entity Framework for Core is the ORM for .NET Core. I did a quick search on Hibernate to see if there was anything going on in the Hibernate world to make it work with .NET Core, and I saw a few kind of posts on their issues board saying, hey, we should make it work with .NET Core, but no real uptake, no real evidence of any effort or industry going on, where meanwhile Entity Framework is having a lot of work done. There's a very, very active GitHub, you see the issues coming in, there's people working on it and working hard. Sorry? Oh, Dapper's still there, Dapper's good. Dapper's got a different use case, and yeah, and if your use case fits it, oh, nothing wrong with Dapper.
No,
I don't know actually. I don't know. I assume so. I don't assume so, so I'll look that up. So Entity Framework Core is open source and it's on GitHub. So it's pretty public, its development, and it's designed to have a familiar developer experience. So you've got your link, you've got your POCO, it's your plain old C# classes. That's how you model your entities, and it's got code first. It's also more lightweight, so it's supposed to be a little bit faster, a little less going on, and basically less of a footprint on the cloud. So what's new? Because it's running on Core, it'll run on more platforms. That's just what you get when you run it on top of .NET Core. It's also, from the ground up, built to be more configurable with dependency injection. If you've ever tried to get the old versions of Entity Framework Core to work with if you've ever tried to get older versions of Entity Framework to work with dependency injection, it wasn't really designed from the ground up to use it. It's a little bit funky there, and that's much improved. It's going to ship with support for other databases, such as Postgres is the kind of one they're focusing on. But the way it's built has much more support to allow other database engines to be swapped in. They also plan to support non-SQL data stores. The one that's been discussed is Redis, which is more of a kind of object store. But that's not currently in the 1.0 release. That's on the roadmap. And finally, there's a new feature which is called in-memory mode, which you can use for integration testing. So in this mode, you've got this kind of fake in-memory database. So you can run some test scripts and act as if there's a database there and test your features. But it doesn't actually talk to a database, it just does this stuff in memory. It's more of an integration test than a unit test. I wouldn't use it instead of unit tests. But for things where you really want to test what is Entity Framework actually doing behind the scenes, I want to make sure it's actually doing what it's supposed to be doing, then that's an extra option for testing. Finally, this seems small, but I really like it. There's much better IntelliSense. When you try and use an item using Entity Framework Core, the help contains much more about how to use it and also the pitfalls of using it. Say, for example, when you use the dbset operations to run a query, it'll explain to you that the query will run against the raw database and not against the in-memory state of your database. Okay, so one feature that's been with Entity Framework for a long time, and a lot of people like it, is EDMX and database first. So with EDMX, you get this fantastic UI tool that lets you kind of see the structure of your database. It plots the tables out, puts lines between them. It also lets you just point it at a database. It'll run some scripts and generate the EDMX files for you. It will generate a whole set of classes and basically give you a data layer against that database as it is. And I think the main thinking behind it is code is hard. It's much easier to just point a tool at it and draw some pretty blue boxes and have it all done for you. In reality, this is what happens. You end up with this quite a big mess to deal with, and finding something here is hard. You've got to just start searching around. There's no Control F12 to open ReSharper. There's no refactoring to ReSharper. So we've got that problem. We've also got some other problems coming along where you've got a single mapping file. So you've got all this configuration in one file. So you're going to have merge conflicts. Yes. I was joking when I said EDMX is awesome. Although, you know, some people stay it. Yeah. Oh, yeah, change it all to JSON and move, yeah. Actually, why don't we stop using databases altogether and just create JSON blobs and store those into somewhere.
Is it awesome or is it not awesome?
Well, I'll let you make your own mind up. So with a single file for mapping configuration, you end up with merge conflicts. ReSharper and refactoring support, you can't really do that with an EDMX file. You've got to click around the UI tools. So I think it's slower than code. With DB first, for me, the most important things in any kind of structure are the navigation property names between items in that structure. That's how you make sense of the world and what's in it and what you can do and how this thing relates to that thing. With DB first, all that stuff is generated. Also, if you remember the point of Entity Framework, it's to take a complicated object-oriented structure and store it in the database. You can't start with a database and make it more complicated automatically. So I think your metadata needs to be at the code level, and your database is actually the store level. So with database first, you're not getting the full benefit of object-oriented modeling. You're kind of limiting what you're doing to just build a kind of default version of object models from what's available from your database. And if you try and go beyond that and actually start tweaking around what the tables are or how it's being modeled, you get all sorts of problems where if you regenerate from the database, you might lose configuration. So I've seen projects where we've been regenerating from database, getting the configuration updated, and then having to go and change 5 properties in the UI by hand every single time because we needed to change those properties around. And that gets very messy and very dangerous very quickly. So in my opinion, code is better than tools, especially fluent expressions. We've got Link now, so the configuration for Entity Framework 6 and for Entity Framework 7 is using a very nice Fluent API. By being Fluent, it's type compiled, it compile checks using expressions to identify the things you're mapping to. So finally, with Entity Framework 7, there is no more EDMX. EDMX is gone. There are no more EDMX files. You cannot do database first. You can't do database first to EMX, and there's no UI tools. So code first is the approach that's used.
In Beta 7, they had a tool to scaffold the database.
Yes. So what they have now is scaffolding, which kind of replaces the what the Entity Framework 6.1, I think, had a reverse engineer from code first thing that was in the EF Power tools that I can never get to work. But there are tools to read a database and generate a data layer from it. It's just not using EDMX anymore. What it generates is the Fluent mappings as if you'd done it by hand. I've not worked with it enough to know how good it is, but I do find it useful sometimes. If you get given a legacy database by a client and you want to do a few quick jobs with it, I've pointed Entity Framework at it and said, give me a data layer, and bang, I've got it. I need to get 3 tables out, make some queries, and the job's done in a couple of days. I would probably still use Entity Framework 6 for that, just because it's quick and easy. Or Dapper. There is Dapper, of course. So yeah, some people are going to miss it. I was speaking to a couple of guys at SSW today, and they're the database first mindset. They think, what am I going to design? I'm going to design a database, and I know how databases work. I know how to make them optimal, and that's the big thing with Entity Framework is you're stepping away from your database, so you're not having the full control of its performance. So they quite like EDMX because they design their programs, they design a database, and EDMX means I can design my database and then very quickly get the code. I think one of the differences is where you think your program lives. Database people think the data's done and it lives inside the database. And what applications do is come along, take out the data for a little bit, monkey about with it, and then put it back again. But the database is where it is, that's where it lives. An object first person thinks, well, the data's dead if it's in a database. It's alive when it's taken out of the database and in memory and in objects, and I can manipulate it in that format. So for me, all the database does is like a file save. It's a temporary data store to put it when I'm not using it, I want it back in that object structure and working on objects. So it's a different way of approaching the same problem. So I think the database first people are going to miss this EDMX approach. So any questions on that, the whole EDMX versus code first thing? Who's going to miss EDMX? It's not a witch hunt, it's okay. So who prefers code first in general? They just like working with code. Pretty much everyone. Well, you'll like Entity Framework 7 then, or Entity Framework Core, because you don't have the choice. So the next thing I'm going to talk about is a DbContext. And pretty much, if you're going to do anything with Entity Framework at all, DbContext is what you need to learn, and it's what you need to master, and what you need to understand how it does what it does. So, and I'm going to focus on what's different between Entity Framework and Entity Framework 6. So first and foremost, it's still there. It's still the fundamental core thing. So when they rebuilt Entity Framework from scratch to do Entity Framework Core, they didn't throw away the DbContext. It's still there, still does exactly the same job. And what it is a kind of combination of unit of work patterns. So they took these concepts in and rolled them up into one central object in a unit of work, in the fact that it kind of does database work, tracks changes, and then it just saves all those changes at the end in a single database transaction. And repository patterns, it contains references to DbSet objects that lets you query the database. And so what it does is it's got support for tracking the changes and runs transactions. And at the very end of your unit of work, you call save changes, and those changes are applied to the database. One small detail that I've kind of learned in this research is when you do some work with your database, and then you do a DbSet, use a DbSet to make a query, that query runs directly against the database and doesn't take into account the changed state of entities in your model. That's slightly different to nhibernate. When nhibernate works, you create a session, which is pretty much the same as DbContext, and if you work away getting entities from it, if you do a request that requires a database query, it will behind the scenes flush your pending changes and query the database so that your new changes are included. I actually prefer the delayed save changes because it's explicit when that save occurs. Having this, and you can change that. There's in Hibernate, there's something called flush mode. It's flush mode.auto, flush mode.never, only flush when I tell you. So, but that is that's one of the clearest distinctions between Entity Framework and in Hibernate. So what you've also got is this first level cache, and an entity that you've loaded from the database sits there in this cache in memory that you could then load from that cache instead of actually querying the database again. Again, it depends how you've loaded that object. If you ask Entity Framework to give you an object, it'll turn it into an entity. If you ask Entity Framework to create give you the DB set, then you query that DB set through a link query, but during that link query, you do a select to cause a rejection. You're not getting entities out. It's going to take that query, turn it into a select statement, and give you just those fields you've selected. So in that point, you've not got objects being loaded in the cache. You're just getting that data straight back as you've requested it. And because it's quite a big object, it's got configuration involved. It's also got this cache with stuff in memory. It's tracking changes. It keeps hold of not only the current state of the object, it's got the previous state of the object. Managing that DbContext is a key consideration for performance and memory use. So let's look at a few things that have changed in the code for working with a DbContext. First of all, there's this new object called DbContext options. And it's also something that you can, it's available as something you can inject with a constructor. You've also got the onConfiguring function here. Actually, let me highlight that. So first of all, you've got a constructor class here that takes DbContext options. You've also got this onConfiguring function, which takes a DbContext options builder. So the role of a DbContext options builder is it's got a whole series of extension methods like use SQL server that configures the DbContext options to use SQL server. The reason it's got this slightly weird structure is DbContext options isn't really a list of options, a single list of settings. It's a container for a whole suite of settings. If you're using something like Postgres, a lot of the settings may be very different. So what would happen if you had the Postgres engine loaded in, it would provide its own set of extensions on top of Options Builder to build all the right things for a Postgres configuration. Or if you're not using a database at all, then all that stuff can change. So that's where the flexibility comes in, is you've got this central Options Builder. When it loads a driver for a different database or a different persistent store, they'll provide different extension methods on top of Options Builder in order to build your database. And right here you've got an example of loading a piece of configuration from a .json configuration file. So the DbContext has a few new base constructors. The options one, which I've shown you. It's also got this new one here. This one here takes in an iService provider. Now, if you remember the startup.cs, that contains a function that registers services up. iService provider is pretty much the entry point for the new built-in dependency injection stuff. So that is a system that you register services against and then pull them back out again. I'll show you that a bit more. I think this particular usage isn't that great. The role of dependency injection system is to give you dependencies. It's not the role of dependencies to have a reference to their service provider so they can mess about with them. So I would say do not use this or this. I think it's there to be flexible. This or an empty constructor or a constructor with the actual things you need to make your DbContext should be injected in, and that should be handled by a service provider, not your service provider pass through to your context. So top one good, but you can maybe create a factory class or something for it, but the bottom two I would say bad. A new object on DbContext is DbContext.model. I quite like this one, although I don't like the API it gives you right now. Previously with the entity framework, you could make configuration and you could do it with your EDMX files, for example, or you could do it with data annotations on the entity classes themselves, or you could use the Fluent API for configuration. Whichever one of those you use, you would set up the configuration, it would go into a kind of black box and you wouldn't really see it again, and you have to just look at the behaviour of the system coming out to work out what's going on. So with this, you get the ability to actually query your model structure, find stuff about your entities, and actually find out, okay, this property, is it nullable? I don't like that here and here you've got magic strings, but I think that's just a bit of syntactic sugar they need to put on. They need to turn that into kind of more Fluent lookups, but the fundamental thing is that you can actually get information back out about how your system's being configured. So you could write a unit test to kind of set the configuration, read it back, and make sure that configuration is still there. It's a really simple test, for example. So one feature of Entity Framework up to version 6 is lazy loading. And I'll give you a quick demonstration. I gave this demonstration last year as well about how lazy loading works and what it does. Any questions on what you've seen so far while I just set this up? Let's find my tests. Okay, so what I'm going to do, I've got an old school EF6 solution here, and I've got a whole bunch of unit tests. I ran through these unit tests in my last talk, but I've got one specific test that does some lazy loading. Let me just talk you through this. That's going to come anyway.
Can you unlock it in front of me?
Yes, I will. Let's find the right place to put a breakpoint first. Okay, so what I've actually got a little factory class here that creates a DbContext. So I'm getting my DbContext here. I'll make it bigger, sorry. See if I can hide that. And hide that. How's that? Okay, so I've got a factory class, which I'll talk about a bit more later. But basically all a factory class is to give you instances of stuff. So I pretty much avoid using the new keyword at all costs. If I want something to be created, I use a factory to do it. And then I can then set up a dependency injection architecture to set up those factories to be the source of any time I want that type of object. So DbContext itself is our disposable, so I put it inside of using. I'm then just loading a student by their name, in this case me. I've got a little assert to make sure it's not null, so that's a little test. And then I'm going to breakpoint right here to see what it is I've got. You can see that there's a navigation property between Brendan and the enrollments collection. So it's a collection of a second set of entity types. So let me run that test. Bring up Solution Explorer, jumping up test. Is that the right one? I think that's the right one. Alright, I think I've got the wrong. I'm going to try this for 30 seconds. My demo has just died. And if I don't get it to work, I'll just talk through what you should have seen. Okay, try it one more time. Stop that. Did that just run or fail? Okay, I'm going to skip that and just tell you what should have happened. Okay, I've got myself into a state. So what I've done here is I've attempted to load an object, but my database, I've obviously run some previous tests in a different version, or my database isn't quite in the right state. So what happens here is I would have loaded a object, which would have been of type student, but I would have hovered over this object in the IntelliSense, and you would have seen that the actual concrete type returned by Entity Framework is not of type student, it's of this dynamically created subtype. I think it's, and what that is, it's something called, what's the word for it? A dynamic proxy. So instead of returning a concrete type of type student, it returns something called a dynamic proxy. And the point of a dynamic proxy is it fills in all the details it has on the raw object, so my name, my first name, my last name. And where enrollments is, it's a dynamic subtype of the student class, so that when enrollments is hit, that's when it'll attempt to connect to Entity Framework again and load that enrollments collection. So that means that when I first use that object, it loads just the properties against it. If at any point during this context lifecycle, I ask for enrollments, it would then in turn go and load that whole collection of enrollments in and fill that in. So it means I can have some quite flexible get code, just get me a student by name. And if I'm using it somewhere else and I'm using enrollments, somewhere else I'm not using enrollments, I can flexibly just write this code and it gets filled in. What's dangerous about that is sometimes you're running more queries than you need to. What you can do when you're running a query is say, okay, I want to include the enrollments by hand, and it'll fetch those for you. Also, if you close this context before you finish working with this object, then attempting to go from this object to enrollments will crash, because in order to fulfill that lazy loaded object, that context that it came from needs to still be open. So lazy loading is a feature that's got some controversy because it's had n+1 problems. It's got people, it can fail, or it causes you to fire more queries than necessarily need to. But also, I find it quite useful. Right now, it's not implemented in EF7 core. So this is a feature that was on by default in EF6. EF7 core doesn't have it yet, it's on the roadmap. So that's quite a big change for me and quite a big missing feature for me. And for me, it makes it hard to say, let's migrate straight across to EF7, because any code that assumes you've got lazy loading in there won't work. But any new project where you're used to the fact that it's not there, you just write the code with that new limitation. So for me, that's quite a big missing feature. It is on the roadmap though, so we'll eventually get it, and there's some quite interesting discussions on the best way of implementing that. But that's an example of a feature that's off by default and isn't there now. So the next thing I'm going to show you is some changes to the Fluent mapping configuration. And I recommend this is the best way of managing your mapping, because you can use annotations, but to use annotations, you're going to make changes to your persistence object itself. Where Fluent mapping, you can add the mapping without making changes to your fundamental core records, your core design objects, domain objects. Okay, so in the latest version of Entity Framework, you had quite a useful little set of things. First of all, on the DbContext itself, you've got this function called onModelCreating that takes in a model builder. And then you've got this function here to actually scan the assembly, and what you're scanning for are these entity type configuration classes. So on a per entity basis, or even multiple items per entity, you can set up this Fluent configuration. So that sets up a max length, that sets up a one-to-many or a many-to-many relationship between this thing and activities. That has changed to just a single function on model creating. So on model creating is pretty much the same thing. The model builder type has slightly changed. It's model builder instead of DB model builder. I guess that changes because it might not be a database you're talking to anymore. But you've still got the Fluent configuration, but you don't have this nice entity type configuration. There are plenty of posts on the Entity Framework issues board about this, and a few people have knocked up their own already, so that's something that will come. It's just something that's nice that you've got before that you haven't got yet in the new version. There's lots of changes around the actual Fluent configuration and the various words, but I'm going to give you one kind of example here because I think it makes it clear to understand why these changes have been made. In this top one here, I'll get the highlighter out. So in this example, we've got two properties that are set up. One has been set up so that this particular property is an identity column in SQL Server. So that will automatically, when you try and save it, it'll just get the next value from that identity, and it's generally used for primary keys. And if you've got a primary key against your object, then it's set to identity by default. This one is something that would have been an ID. It's an ID, so it would have been considered an identity. But in this case, we've said, no, don't generate an identity for it. So if you're integrating with a third-party system, you've got a whole set of records and the IDs are been set by that system, but you want to copy them into your system, then that's the option you'd use to keep the same key. That's changed slightly, and the big change in the wording is the word identity is gone, and instead you've got value generated on add and value generated never. The clear reason for that is because identity is an SQL Server concept. In a lot of other databases like Postgres or Oracle, you don't have identity columns, you have sequences, and you set the primary key to be the next value from that sequence. So there's a clear example of something that's changed. The wording's fine, but it's changed, and and the reason is to make it more generic. One-to-many mapping is when you've got an entity and it maps to a collection. This is something that's very easy to map in databases as well. You just have foreign keys on the collection objects all pointed back to the first object. And that's pretty much the same. Slight changes. Instead of having many with required, it has many with one is required. So it's kind of specifying that it's many to one, or one to many, depending which order you put it. But then the is required is true. So it's trying to separate out the two concepts. With one and is required are two kind of concepts, rather than with required means it's a one to many with it required. So the next one is many to many. This is quite a cool feature of EF6, where you've got one record and you've got one entity and another entity, and on each entity you can put a collection on this side that points to that one, and a collection on this side that points to that one. What Entity Framework will do will automatically generate a table in the middle just to manage those keys to make that many-to-many relationship. Unfortunately, that is not currently implemented in EF7. That's quite a big one for me. Again, this one is on the roadmap. Your workaround right now is to create a middle entity in the middle and basically make two one-to-manys. But I'm not happy with that one, to be honest. So that's something that's going to hold me back from taking it up. Again, it's on the roadmap, it's just not on the roadmap for version 1, and I'll show you the roadmap later. Another one that's changed quite a bit is there used to be a class called the DbInitializer. And there was quite a few things I didn't like about this class. So you had this initializer set, and this particular initializer, so the initializer itself, what I'm talking about, is this class, migrate database to latest version, give it the context, give it some configuration. So what that does is apply pending migrations to update the schema you've got against your database. What I don't like about this class is in order to use it, you register it against this kind of top level object, this database object. You call the setInitializer function and say, so what you've got is one global object that you talk to set up the configuration for the DbContext. That's changed quite a bit. The way you do the same thing now is against DbContext is this facade class called database facade. So that gives you access to the database you're talking to. And then you've got, so the equivalent of that one is the migrate. You've got ensure deleted, which in testing you delete the database before creating it again, and ensure created, which will take the latest state of the model database and actually create a new database. And migrate will be, you've got a database in place, you've got some new changes, apply those new changes in schema to your database.
Can I ask, is anybody using those automatic migrations built by those fancy tools?
Yeah, the question there was, is anyone here using the migrations as built by the migration system? My answer is yes, but not automatic. You've got one setting in the Entity Framework 6 thing where you can say use automatic migrations, where when you point the system at it, it'll generate some migrations and automatically apply them. That's just crazy. I don't do that. But what you can do is you run migrations and you run the migration script and it generates a kind of change system. And then when you start up your database, it'll apply those changes when you start your application. So you deploy your application. When your application starts up, it notices it's pending migrations. The first time you try and hit your DbContext, it'll then apply those migrations and make your change scripts. But you can also overwrite the code that's been generated. So it'll generate code for you, it's readable. You go in there, change it. If you've got some data migration scripts, like you're changing types around a little bit, you can actually do your code in there, just write raw SQL, move a field out, rename it, put the data back in. You do it that way. So dbset.find is quite an important feature because what this one does is you actually get an item from your context by ID. So if the item's already in memory, you know you're getting the one from memory. So this is how you use your first level case. Again, it's not quite there yet, not implemented in EF7 yet. There is an extension method that people have written on Stack Overflow, and the guy that wrote this extension method does have commit privileges to Entity Framework, so this guy knows what he's doing. So I would actually take that piece of code and add it into your project if you want to use, well, you should use that. So add it in. This particular issue has been marked in the Entity Framework's issues board as priority issue 0, as priority 0 for 1.0 release. So I'm thinking that should be coming very, very soon. But right now, it's just not in there. So any more questions about those, or comments about those things we've seen so far? I'll move on to the next section. Okay, so Entity Framework migrations is how you track changes to your entity structure and then update your underlying database schema to match. So the first thing that's changed with migrations is the old way of doing it is an add migration PowerShell script. I think in the future we'll look back and see how we used to go and open up the NuGet Power Manager, the NuGet console, and use that as our primary console. A bit weird. We seem to not have a good console for a long time. Then finally NuGet came along and we got a console. And then when they came along to kind of make Entity Framework, like, well, there's a console here, we'll just use that. I think the console tools are going to get much better, and subsequently the console tooling in Entity Framework is going to be better. I think that people have finally realized that some people like working in the console, and let's give them a good one. So that's changed a fair bit, mainly because PowerShell doesn't work on non-Windows platforms. So if you want to run it on Linux or you want to run these migrations somewhere else, PowerShell is no good. And so what they've got is DNX commands. And I'll show you how DNX commands are run up. So you call this from the console, you call DNX, and then EF gets you in there, and then migrations is one of the commands. So inside the project.json structure, you see what we've got here is the top highlighted bit actually wires in the NuGet package that contains the commands. And the second highlighted section actually is there's a specific object in the project.json structure that sets up commands. If you've got a web project, you might have a web command, which will start up in-memory little web container service, little self-contained web service to serve your web pages. So that's how Entity Framework, the command system of Entity Framework wires itself up to your project. How Entity Framework works has changed quite a bit. So what Entity Framework Migrations does is it looks at the configuration and objects in your model and builds a kind of model object based on that. And that model object in the previous version of Entity Framework was actually written into the back end of a designer file and stored in this big blob. And that blob was actually written to the database as well. So it was pretty unreadable. You'd know it happened. You'd be able to, it would detect that you'd done the wrong thing and you've messed up your history and you have to roll back and to fix it up again. But you couldn't really read what was going on inside there. What it generates instead is, and I'll switch to the highlighter, it generates code. So instead of having this structure that's been serialized out base 64, whatever it is, it actually generates this fluent code. So if I know we've got an entity, its class, So we know we've got this entity and its class name, and we can see the properties that this system has set up for the model builder. So that's a massive improvement on how to kind of see what it's doing behind the scenes. And how that plays through into the database history, in the previous version of Entity Framework, it would put these ugly blobs here in the database. Now it doesn't need to, it just has a name, Entity Framework's version number, all the information's in that file you've just seen. So the information is here in a readable form, in a code form. So the computer can read it, you can read it. And that's what I haven't shown you, is what an actual migration looks like. So I might just drop out and show you that. I'll show you a migration from Okay, so when you generate a migration, this is still Entity Framework 6, Entity Framework still works in the same way. What it generates is this type of information. So you can rename a table. So it's very readable stuff. And what you've got the option to do is just type SQL here. You can just type SQL here and run any SQL queries you like against that database. So it builds all this stuff for you. So the only thing that's important is you've used the scripts to generate this migration, because behind the scenes of this migration is all the stuff that is all that memory blob. And actually in the new version, you've got a designer file with a model state in that fluent pattern. These are the commands you're actually using to change your database. So you can drop a primary key, you can add a primary key. It's also got up and down functions. So you can generate this, use it exactly as it is. If you've got a far more complex migration to handle, you say you've got to merge some data, you've not just adding and removing a column. You need to add a column, copy it from an old column, and then get rid of the old one. This is where you'd do it. So you'd insert between your drop and add, you'd insert some SQL to do that copy operation. And I've not really had a problem with the code that's been built by this. So I find it's very stable. This code that it makes for you is very good. The only thing I've ever needed to do is if I need to do something more complicated with actually migrating my data rather than just changing the schema.
With these migrations, how do you do a production deployment? I mean, like how, for example, in my data application, there is already some data which already be there, some data.
That's right. So
how do you deploy it?
Okay, so the question was, how do you deploy these migrations to production? Because on production, there's already data there. And that really is depending on what the migration is. So what we typically tend to do is we just deploy the latest version of the code, and that initializer I showed you earlier, that's the thing that says when you start up, so the first time I make any kind of work with the DbContext, that's the point to run migrations. So then migrations picks up and goes, okay, I've got these 3 pending migrations, and we'll apply them to your database. So it won't fire a query until those migrations have been applied. Then it's a question of what those migrations are doing. Obviously, you've got data in there. If all you're doing is adding a new column, then you're fine. If you need to add a new column, you can also specify default values in those migrations. So if it's a not null column, make sure you put a value in and it will go through. And the only thing that's a problem is if you want to do some kind of data transformation. You've got data in one form and you want it to be in a new form. That's when you get into that migration script and edit that script. Because the migration system can only see that you've added a column. You can't see that I actually want to take the data out of that column, convert it, put it in that column, and then pull the value out.
So, can I be devil's advocate?
Yep.
I'll just get you that answer so he doesn't have to repeat the question.
Can I be devil's advocate?
Yep.
How do you deal when you deploy this to a cluster of 50 servers and they all start about the same time?
Yeah, so I think in that case, I would not use initialization. I would make running that migration part of the deployment process, not part of the application wakes up and then deploys itself. It's pretty easy to do the application wakes up and update yourself, but for more solid, I mean, maybe you've got a cluster, you might not have a one-to-one relationship between your web servers and your database. So in that case, I'd definitely have part of your deployment, so I'd have an Octopus deploy script that woke up, had just a little console program, just the migrations, and then do it that way.
So this is not really scalable. It's just good for small projects that you have very good control of when the application starts.
Well, it depends. I mean, at some point, you've got to deploy your database changes. Depends on how you want to do that. But yeah, you can take this stuff out and script it. You can also use this same engine, but instead of applying the databases, generate the SQL. Generate a set of SQL changes and deploy it that way. So you've got a few options there. You don't have to just let the migrations engine do it.
So one problem I see with this is if, say, you don't want to give your application code access to manipulate the schema, which is the case.
That's a very good point. In that case, what you do is you basically don't do it at application startup, do it as a separate process, a separate deployment process that can run these migrations, and give just that deployment process the access it needs to make schema. And I fully agree with not running the application with the rights to change your database if that's a consideration.
It feels very dangerous to me to have that in
Yes.
code.
Yeah.
If anything goes wrong, you're stuck. You're
Yeah.
dead.
I would do it in production.
Yeah.
You're doing production.
How can you double check that the schema is as it should be?
What do you mean as it should be?
Exactly like as it is in test and staging.
Well, it depends. I mean, there's a bunch of tools. We've got a little tool that is called SQL Verify, and we've wired that into our initialization steps. What we do is we just when we've finished applying migrations, we run a quick query that gets the list of all the tables, all the columns, turn it into a big cache, save that hash against the database. So what we're really looking for is someone coming in and making unauthorized changes, like someone else messing with your database, because that can actually mess about with your next migration, because migration assumes a state. So SQL Verify is a very, very small product because it solves a very, very easy to solve problem. But there is something we'd use. How's that not helmet up? And there we go. What came up was we've also got SSW Health Check, which is a program we've got that you put on a web server and generates a page of ticks for all the states. And one of the checks we do is for SQL Verify. So that's one tool we have that lets us do that. So we've got SQL Verify core that runs against any database, SQL Verify.ef adds the bits that was into the whole migrations process. But at the end of the day, the whole migration system, if you don't want to let that run by itself on production, just use it to generate the schema and then read the schema yourself, send it to your DBA, make sure your DBA is happy with it, and let the DBA do it in his own time.
If those code-based migration steps fail for some reason, maybe the database isn't quite what was expecting, what happens? Does your app stop starting?
Then.
Well, that's right. I think if you
the rest of your app doesn't
if you're
warm up,
if you're trying to push that schema changes and they break everything, you're always a little bit stuffed, aren't you?
And is it wrapped in some sort of transaction or anything like that as well?
I believe it's wrapped in a transaction. Yeah, I'm sure you could use transaction scope to wrap it in a transaction as well. There's nothing stopping you putting transaction scope. I mean, it's all code that's there. So start up a transaction scope, wrap it, start and finish, run your migration program, and then close it.
You just talked earlier about developers liking code.
Yeah.
And now it feels to me that we're developers trying to write code to what should be SQL. Yeah. Like
there is
SQL,
an element of that. Your DB admins aren't going to like it. Yeah.
To write C# because we're too lazy to write SQL or to understand SQL.
There is an element of that. Yes. Yeah. Definitely. I mean, you're on this. You're hitting the nail on the head with this. There is this two types of people that are object people and don't really care about the database, and people that are database people that don't want the applications breaking, app developers breaking the database. And there is tension there in the world. Yeah.
Quick question. How does it deal with knowing if the database has already been upgraded? Was there a version table or something?
Yes, there's a version table. That's one of the slides I saw earlier. So it knows which version it's up to, and I'll throw an exception if it can't see how to get forward from the versions you're up to.
I have a question.
Yep.
I don't use data migration, so I'm just curious. How does it deploy CLR stored procedures?
You just run SQL.
Is the only person that actually uses them?
Yeah. I showed you earlier.
No, but they're quite. If you're dealing a lot of like string objects and all that, they're much faster than SQL Server stored procedures.
Yeah.
Or stored procedures for that matter. How do you do?
Yeah.
Okay, forget about CLR. How does it do stored procedures?
Okay, well, you've got the you basically inside your migration script, you can just run any SQL you like. So that's how you do it. It doesn't have a specific support for anything other than it's got a few commands like create a database, add a column, that kind of thing that is in that thing. But one of the commands it has is SQL. So you can put in any SQL you want and deploy whatever you like in there.
SQL is C# because that's what developers do.
Like inline SQL then.
Yeah.
Okay, thank you.
Yeah.
So I think the conclusion is don't use it unless you're doing some very small home project. Because the second you deploy in a cluster, or the second you have production with data, the dangers feel just crazy.
I think if you're doing like things like clusters, you do need to you can use it to extract your SQL out and then take control of your SQL and change and push your changes like you do any SQL changes. At some point, you've got to push an SQL change that might break your database, and there's no getting around that. If you've made there are schema changes and migrations that can lose data, that can make a migration or transform data. If it hasn't got a second copy of that data somewhere else, it's broken and you can't go back. So,
I might make a comment. I don't think it's for home projects. We've got hundreds of customers in Sydney, large enterprises running it. It's not home projects.
Yeah.
No, I think what we even we use entity framework quite a lot. The only way we are saying is that the migration, the automated migration, is something which is not something we would like to use in production. Yeah. We would use SQL Server project or something for doing it, but entity framework would be used for doing data access and all.
Yeah, it feels wrong. I mean, the security perspective is the first thing.
I'm not for a moment suggesting use automatic migrations either. I'm saying never use automatic migrations. You can generate these scripts. They give you a starting point. You can then change those scripts as you want.
Correct.
Yeah. I would never say there's a setting called automatic migrations that will run that stuff and run it against your database. Don't turn that on. You can generate these scripts, get 90% of the way there, and then just fill in your stuff. Yeah.
And then you might do a red-gate compare against production.
That's it. All the tools you generally use, you can still use. It's just a quicker tools for the developer. If your database structure is complicated, then by all means generate the scripts out, go over those scripts in a fine-tooth comb, rewrite them as you need to, and go from there.
Another quick question about migrations. I'm wondering if anyone has like any nice tools that allow you to basically, let's say you want to have two web apps where one of them sort of your new one and one's your old one, and you could sort of conditionally, if the set of scripts didn't run, the transaction didn't commit, then it would use the other web app instead of the new one. So it'd be like a graceful rollback that's all automatic. And
possibly, I haven't seen such a tool, but I mean you can generate the scripts and turn it into SQL and send that through to DbUp.
Yeah.
If that's what you want to do, and use DbUp to deploy. I don't know what DbUp has, and Octopus Deploy and their DbUp stuff, they kind of say, if we have no rollback for database because you've run a set of scripts against database with no idea what you've done and how to roll it back. So you need,
You can't do transactional of scripts.
No.
DbL scripts.
Ah, right, yeah.
Even if you think you can, transaction even TSQL, any transaction, rollback transaction. If you say update table A column, it's happening.
Yeah.
You need to use the mic so we can get complaints.
Yeah. Yeah. So I'm not trying to say that updating a database isn't scary if it's a production database, and whatever tools you use, you can still use them.
So I've got just a couple of commenters here. Dave Lane, if production has made changes to the database schema because the database is used by more than one application, how do you sync those schema changes from the other app back to your code first application?
That's
similar to how you do it in a Visual Studio database project.
That's pretty difficult. I would say code first is really one application, one set of databases. Sharing that database between two applications, I don't think it works that well. I don't think it works that well at all. So there's your limit. If you've got the structure where you've got one big massive database and then 10 different apps, and that's how your building's set up, then I don't think this, certainly not with the migrations generation. You can certainly, what you'd have to do is just manually change your configuration and not use migrations. Actually go database first, and you can actually reverse engineer from database first. So one option you have is you can run scaffolding scripts to look at your database and generate your code first kind of style from that. You can also just do it by hand, actually manually set up your migrations. You don't have to use the scaffolding. All the tools that are there are still there. You can just skip the scaffolding on the migrations and work with it that way.
All right, I have a couple of other comments and questions. This guy says, is there a tool for moving from EDMX or DB first to code first? Or do I have to recode?
No, there's no tool. Yeah, there's no friendly upgrade path from EF6 to EF7.
Regarding the, I'll just send you this. Regarding the migration versus server farm, perhaps you can do it with a lock system. If one instance is already started, don't run on the next instance, etc. Or check that migration table. If there's a record already in there matching the migration ID, don't bother running since someone else has already started. It depends on when that record is created, I guess.
Yeah, I'd say it's safer not to have two things capable of doing the migrations in the first place. I'd have one central thing that's in charge of doing the migration.
And he's also given you just a link that you can generate a SQL script from migration.
Yes, you can, yes.
This is just a comment for the guy who wants to move from data first to code first. Unless you have a good use case for it, I'd say don't. There is no need. Don't do a change for the sake of change.
Yeah, I'd agree with that, because there is no good upgrade path. You just
but if there's a
new
technical
bugs.
reason,
Yeah.
yes, then by all means do it. But unless there's a technical reason for it or a use case, don't do it. There's no need. There's no reason.
But I think that should be pretty simple to do, because there is code first from database first, code base from database
yes,
first.
there
which
is that
there.
code burst from database.
So
yes.
basically, in our application, there was
Yeah.
what we did is like we created the database, but after that we generated the classes and we just moved as code first from then.
Yeah, I think the fallback on code first from database first is you're just going to get a very vanilla object structure. You're going to get what the default thing is for having a table, and if you've got anything more complicated, you probably have to change your mappings around. But it's possible. It's possible. So I don't think you'd generate from database and get the exact object structure you want. You'd have to, but you might get 90% of the way there and then change your configuration around. Yeah.
Very little changes were required to be done. When
Okay, so you've done it and it was
we have done
fine.
it already.
Excellent. Good to know. Okay, I'm going to move forward now and talk a bit more about dependency injection, and really about how Entity Framework uses dependency injection and how you can make it work with your own dependency injection. Okay, so we've seen the startup before. This is your startup class, which is kind of standard in your new .NET Core projects, so your new VNext projects, or whatever the actual container is called. And we've got this as standard inside your startup project. There's this method called configure services, which takes a service provider and a service collection. So what Entity Framework registers are extension methods. One is add Entity Framework. This looks quite similar because we've got one that's add MVC. So pretty much most packages you add to .NET, MVC included, Entity Framework, add some extension methods that you can then add onto your services collection and then configure stuff up. So this is kind of your default way. This is the way I'd recommend configuring Entity Framework, because it's wired in to the kind of standard configure services dependency injection system. But going beyond just the startup, this iService provider is used throughout Entity Framework internally. So how Entity Framework is built, all the layers do dependency injection properly in the fact that different things get fed their dependencies by the container. So what if you want to take this default dependency injection engine and use your own dependency injection engine? I do find I use AutoFac a lot, and AutoFac's got some nice features that I like. One of the ones I like is that with the default dependency injection system, it'll just, when you ask it to get you something, it'll use just the first constructor it finds. AutoFac will scan the dependencies that got registered and find the constructor with the most parameters that you've got services for. So it'll find the best fit, the one that matches better. And you can always just tell it, now use exactly this constructor with these particular things. So they use AutoFac with the iService provider. AutoFac have been pretty up to date on getting this out. They've added some new functions here to actually take the services object, create a AutoFac builder, and then actually populate that builder with services from the previously configured service provider. And then at the end of the configure services function, where you return the service provider, you're actually returning a service provider object from AutoFac. So from that point on, it's AutoFac that's serving the actual requests, not the inbuilt dependency injection system. So to use that a bit further, I've actually shown you what I've registered here. I'll get the, after calling the builder, That's not very good. So after calling the builder, after creating the container builder from Autofac, I've registered a module. In this case, it's a data module. And then in this case, this data module, one of the things it sets up is a DbContext factory. That's a very simple class that just says, okay, if you want a DbContext, here's got a create function, we'll create the DbContext for me. So here's the DbContext factory, and here inside the DbContext factory, I've actually created a new service provider, and this is where I've got my entity framework configuration. Let's get the highlighter. So now I'm inside a factory method. It's got a create, and it's creating my DbContext. I'm actually saying, okay, get me a default from EF core dependency collection thing. I'm running all these functions. And I need to use this kind of thing for this because all these extension methods work against the service collection. So I'm running all that to configure entity framework using the default built-in dependency injector, building that DbContext and returning it, and then it's Autofac that calls that. So a mixture of two dependency injection frameworks are being used. The inbuilt DbContext does need to configure itself against the iService collection because it uses that right across the board. I don't know if it's, you could obviously replace all this with your own setup, but these methods, these extension methods do quite a bit of work. At SQL Server doesn't just set one value, it sets a whole suite of classes that it needs, a whole chain of dependencies that are required for the SQL Server driver engine. So next I've got a bit of a demo to show you, which is how using this dependency injection engine you can actually hack Entity Framework and swap out a bit of functionality. I'm going to try and go through this quite quickly because I'm running low on time. But I had a problem, and there's a problem actually inside Entity Framework that when I was running, trying to actually find out if my database exists or not, just doing a test case, it was falling over with a timeout. There was one piece of code inside Entity Framework that wasn't working very well for me. So I'll give you a quick demo of how to go about fixing that. So first I got my debugger out and I started digging through. And actually managed to track it down to a particular line of code. So I'll just run the test line of code, bearing in mind that everything. Sorry? I'll make it bigger as well, yeah, as soon as I get it running. This one. Okay, so I tracked down, stepped through my own code until I got to this line, dbcontext.database.ensureCredits. This is something you can run pretty much at startup to make sure that your database is created. Obviously, if you're not managing your database from your code and manage it somewhere else, you wouldn't bother doing that. You might just check it. Or you could, see what there isn't is a function here that actually checks the state of your database and just says, are you up to date? Die if you're not. So I think that's something we do need to have added. If you're not managing your migrations from the code here, you should be able to just check it and die if it's not up to date. So that's a feature I'd like to see. But I found I was running this ensure created, and when I stepped into it, it would just freeze up. F10. It would freeze up and I wouldn't see anything going on. So what I did is I'll just show you how to step through. So first thing I looked at is here. This object against DbContext is called a database facade. Well, that sounds pretty reasonable. So I know what a facade class does. A facade is something that takes a complicated big thing and makes it look like a simple thing when I'm using it. So I can only assume this system plans to have lots of databases. All those different databases could be very complicated and have loads of settings against them. But when it comes to working with the DbContext, it's going to have a very limited set of functions. And one of those functions it has is this ensure created function. So no matter what database it is, that's the way you're going to use to actually ensure this database is set up and created. The other thing I can't work without is resharper and the decompiler for resharper, because I can now go Control F12 on that object. Hopefully it decompiles and goes straight to a decompiled version of that file. So now I can start poking around in here and look around to see what's going on. And I eventually tracked down, if I find the ensure created, I've gone to DbContext, sorry, I've gone to the wrong one. There it is. So there's my database facade. Try F12 again. So through digging around here and there, I found my ensure created. Cool. And then I saw, okay, this looks quite familiar. I don't know what this is, but database creator. That looks like it creates a database. That's pretty well named. Let me make it bigger. Sorry. So I found what looks like some kind of dependency injection service locator. I've got a function called getService, got a function called iDatabase creator. Okay, well, let's look for that. Control F12. And I found a couple of things. Something called SQL Server Database Creator. Well, that sounds like the thing I'm looking for. So I opened up that. So I think that's the class I'm looking for now. Next thing I did was download Entity Framework itself. So I went to GitHub, made my own copy of Entity Framework, and actually found SQL Server Database Creator. Then I dug around in here and found there's a bit of code here that checks whether my database exists or not yet. And the way it does that is it opens a collection and closes a collection. But it had a few bits of code that had been added over time to kind of catch different exceptions and do a retry. And one of those reasons was there was a particular case where one database wasn't ready yet. It threw an exception, they did a retry, they cleared the connection pool, tried again, and it works. They put this looping code in for a few retries. My problem is I was hitting this retry loop with a timeout. So I was hitting the timeout, getting a retry, hitting the timeout, and it was, looking at 5 minutes, 10 minutes of just sitting there. So what I could do next is I could take that class and make my own subclass of it. So previously if you've got an application that doesn't have good dependency injection support, what you have to do there is take that piece of code, change it and recompile it, the whole thing. What I could do instead is take this class, make a subclass of it, and just wire in that changed class. So going back to here, I created my own. Let's see where I put that. Create my own subclass, so I just overrode that class. And one thing that's clear is all over the Entity Framework code, they're not using internal too much. There's nothing worse than you get an open source project and you find something that you want to change and you can't because it's internal, so you have to change quite a lot. So none of this stuff has got the internal keyword, it's all overrideable. So I then just created my own override of that, obviously implemented a couple of constructors to get it to wire in, and basically swapped out a few bits of that exist function, so it doesn't loop, it only loops twice now. Then finally, I needed to wire that in to my configuration. So to do that, I went to my factory, and this single line of code. So right here, we've got our service provider, we're wiring in configuration, and right here is a line of code that says, take the SQL Server creator, swap it with SQL DB creator. From that moment on, and actually how I found how to do this was I actually did a search for that original class through the Entity Framework code base and found where that was registered by default when you use add SQL Server. So I found that line of code, so I knew it had to be server-side.scope to assume it's a limited scope object, some kind of lifecycle management. Swap up that class from that class. From that moment on, if I try and when I try and create my database, it's using my class instead of the SQL Server class, and the bug's gone. So that's one example of how building something from the ground up with Entity Framework, even a big library, becomes much more usable if you can swap out bits of code. Obviously, I would put in all kinds of comments around here. To do, check it. Obviously, what I'd like to see is that little issue fixed, but for now, I'm able to carry on my piece of work. Best thing to do is obviously what I have done so far is raise that as an issue on the Entity Framework issue board. If I get around to it, I might even submit a pull request. So that's the best way of going around this. And we were thinking of ways of like guaranteeing that you come back and check this later. I've put some comments in there. One thing I was thinking of doing is either creating a unit test that could test this, but it's hard because it's a unit test against a real database, so it's not really a unit test. The other thing we thought of was just creating a test in the unit test that's set to fail in 6 months' time. So in 6 months' time, you're going to get a failed test. You go in and see, okay, is it fixed? You can go and take a look, see if it's now working, and get rid of this line of code. Because I don't want it to stay there. It's just temporary while this debug's there. So I showed you how to use ReSharper and .peek to browse in, find a problem, get code from GitHub and find the actual class, and then override that class to create an alternative, and then use dependency injection to just swap that out at configuration time and carry on with a change system. What I found with dealing with Entity Framework is the issues board and associated Stack Overflow stuff is populated by great people. So get on there and see what they have to say. Discuss stuff with them. So level 1, get involved on GitHub and actually post your problems you find. Level 2, submit a pull request. I plan to do it with my little change there. Get a pull request in there and help make the thing better. It's there, it's in the open, you can help.
Before we move on, Ben from Belgium, he just made a comment, check the date and throw an exception in the code.
Is that what you said?
Yeah.
I just said that, yeah.
And he also said that was an awesome discussion on migrations. I've never had an Entity Framework migration fail for any customer. Also, you should split up your database. And by the way, Entity Framework migrations are always wrapped in a transaction.
Ah, there we go. Okay, my next section is on DbContext lifecycle management. I think I'm going to kind of skip through a bit and show you some slides and kind of show you where to find more information. It's quite an in-depth discussion, this one. But the key point is the Entity Framework is a heavyweight database system. If you don't use the resources correctly, you can start getting some serious slowdowns. It is terrible at any form of batch processing at all. Just don't do it. Just go and write some SQL. Seriously. So what you really need to do is manage your DbContext. So the first thing I'd say to you is the easiest way of managing a DbContext is create it, don't hold on to it for very long, and close it off. Make sure you dispose it in a using statement. If you do that, nothing will ever go wrong. It's safe. The only problem with this is if you want to do lots of different operations, lots of different business object operations across lots of different functions in that one context. Because then you've got to pass that context around. And there's nothing wrong with passing that context around, but developers are a bit lazy. So they started looking for other ways of having a DbContext open longer and getting rid of it later. And there are some advantages of having a longer lived DbContext because of that first level cache. So another pattern you see quite a lot is the context per request pattern. In this pattern, you obviously only works on the web, and you create a context for that request, keep it open for the life cycle of that request. You might call save changes a few times, and then you make sure it gets killed at the end of the request. Artifact's example of how to do this is using the instance per lifetime scope function. What that does, what Artifact does, is for every single request, it's got a container engine. It creates a child container for every request. Anything registered used in that child container that's marked as instance per lifetime scope will be closed and disposed of when the request finishes. When that request finishes, Artifact picks up and closes that child scope, and the child scope closes the other items against it. So there's a few things about context per request. It's good for web applications, but only good for web applications. It's pretty easy to understand and implement. You know where you are. You've got a good natural boundary to limit the size of your context because your request should never be that long. You might do a lot of things in one request, it might be quite a complex operation, but there is a natural limit. You'll finish that request, you'll get your context cleared, and away you go. Having a context living for a long time is a very dangerous thing because it will start filling up with memory until at some point you've got your whole database in that memory and your system slows to a crawl. It doesn't just fill up, it slows down in a very, very nasty way. So as long as it's kept fairly small, you've got some possible performance gains there because you've got that first level case available. There's a few downsides for this though. It only works for web applications. You've got any code that's outside a current web request, so you've got startup code, you've got a back-end thread you kicked off, there's no request there to go and look at the context from. Depending on exactly how you've injected in your different bits, you might have a problem with async. You need to really get to understand how your website and your particular dependency injection container manages child scopes. I know I had problems with structure map for a while and found AutoFac easier to manage. I found the web tools for structure map were written by the same guys, where structure map has a very good dependency injection container, but there was 3 or 4 different implementations of website stuff for structure map, and they didn't have the same usability for me. And the other thing to keep in mind with the context per request is a save changed in one place may include changes you made somewhere else. I actually had a real bug here where I was working with another developer and they were doing one little bit somewhere in the request and getting some information out. I think it was like a little kind of header, like, you know, hi, my name is sort of thing. And what they did is they got an object out of Entity Framework, and in order to put it onto the screen, they had to change it slightly. They had to merge 2 fields together to make a nice name. And what they did is they, instead of making a separate view model and copying the values in, they took the object from Entity Framework and changed a couple of values and used those values on the screen. That meant later on in the request, when I hit save changes with my work, I was actually saving that change unrelated, it shouldn't have been a change at all, into my database. So really the rule is if you've got an object that's a persistent object from the database, don't change it unless you want to save those changes. Always copy into a view model to change in a different view model structure and send that out to the screen.
I think one of the beauties of the EF, sorry, I'm interrupting here.
Yeah.
One of the beauties of EF, you actually can request objects with no change tracking. So they are
You can,
disconnected
yes.
instantly.
Yes.
So
Yes.
the way we made the rule in what we're now building with EF, everything you request, unless you specifically request for update,
Yeah.
will come as without change tracking. So even
Yes,
if people
yes,
do
no
accidents
change, yeah.
like that, it's just an object in memory that vanishes.
That's right. Yeah, so no change tracking is something you can do. Is it on the whole DbContext or is it per request?
Per request.
Yeah, so actually on the DB set, it's actually on the link query itself. There's a as no tracking extension method that you call on that query. I've seen some other systems where people actually have a specific context just for read-only, and they actually inject that as no tracking to any time you try and call a query. But the as no tracking works fine. It means you get that object, it's not tracked, it's not stored in memory. And,
It's also faster.
yeah, it makes it much faster because it's the tracking that slows it down. There's a huge speed up with not doing the tracking. Another pattern you see around is called the ambient or thread static context. This really became the way very early on in the Java world. Thread static and session per request is pretty much the same thing, because in a Java container, the way they deal with web requests is that every single web request gets processed by one thread, and that one thread is kept through the lifetime of that request. So the very first implementations of this session per request pattern, it was called session because it was Hibernate, that was done using a thread static. You could just put a thread static against the request at thread, and that would live the lifetime of the request and you can clear it off at the very end of that request. But ambient thread static context can be used outside of web request because, and in fact, structure map has this scope called HTTP or thread local. So that one will look for current running HTTP requests. If that exists, put it against a web request. If not, make it a thread local. And that's structure map. So some DO containers support this as a fallback, and there's still the possible performance gains. This has all kinds of problems though. Problems for async, of course. You've tied it to a specific thread. And so async monkeys about with what threads you're using, and you can't be guaranteed what thread will come back, so async's out. Doesn't work for web requests under ASP, because actually your current thread isn't guaranteed to be the same thread through the lifetime of that request, which is why HTTP.current is used, HTTP.context.current is used so much, and thread statics, a lot of people in .NET have never used them. So there's a final scope thing I want to show you, and there's a blog post I read at some point towards the end of last year, which Gerard actually sent me this. You sent me the post. And this guy called Mehdi who lives out in London, and he came up with a engine that kind of solves a lot of these problems called DbContext scope. And the way DbContext scope works, it pretty much copies what they had to do for transaction scope. You ever use that transaction scope object where you can just put, using transaction scope, call all kinds of other stuff, and if you do another transaction scope, you've got the options to, okay, I can do a new transaction, I can join an existing transaction, I can do a sub-transaction, so if your database supports it, do a child transaction, I can roll back just that bit, but have the parent transaction still running. So all those things are available from the transaction scope object, and this DbContext scope takes kind of inspiration from that. When async... Sorry?
But it's not transactional.
What is?
So it makes it look like a transaction, but it's non-transactional across the different DB scopes.
A transaction scope?
This one.
This one? It's not?
No, it's not.
Okay. So you've tried this one?
No, simply EF doesn't support distributed transactions, so you can't escalate the transaction across two DB scopes.
Okay,
it does look fancy,
yeah.
but
Yeah.
I don't think it's transactional.
What if you're using transaction scope though? That
Transaction scope is not supported in EF7.
And that's not supported in EF7?
No, they have their own transaction model.
Ah, right. Right. EF6 did though?
Yes,
I never used it.
Yeah. Yeah, I've used transaction scope with EF6. I wasn't aware that transaction scope doesn't work with EF7. And actually, this way of managing, we're trying this out right now with EF7 and seeing if it works. Good to know that it might have issues with EF7 because transaction scope doesn't work. Yeah, that's what we're looking into. Good bit of news. Okay, well, I'll skip forward this then. On EF6, this works like a transaction scope. It has an ambient context class, which is a good way of injecting into a repository. And so it supports ambient scope pattern. This particular DbContext scope can work with multiple DbContext. So you've got two databases, you've got a logging database, or you've got a database for something else. Then you can put them both. And what it actually does is just call the two transactions and wraps it up in a transaction scope. So if EF7 doesn't support transaction scopes, this stuff won't work. But what it does do is it works with async, because it uses the same engine that transaction scope uses to actually register an async call. So when you go to the side of an async and come back, that transaction is still there. You keep that reference. I can't remember the exact details. There's some top-level container that you register stuff in. Sorry? Logical scope, yeah. So it goes into that logical scope, and it's still alive across the async boundaries. So on the negative side, I don't know yet if this stuff works on EF7. It might be overkill, and for a website, context per request might be easier. So the final thing I'm going to talk about is onion architecture. And the reason we like onion architecture is it's all about managing your dependencies. Managing your dependencies is the best way to avoid writing spaghetti code. I've already done a very long talk on this. It's available on YouTube, so please go and look that up. So the core concept of onion architecture is you define the things in your database as core entities, and then you build repository interfaces, which is how you manipulate those objects. And so at that point, you're not even specifying how you're using it, what database you're using. I would say use one key thing for using repositories with Entity Framework is those bits of code that are far too slow for Entity Framework, you can rewrite them. Because you're using a repository, you're hiding the details. Put custom functions in your repository to actually find the slow bits and do them not through Entity Framework. Obviously, if you're not doing Entity Framework and some mixed, you've got to be careful about your change tracking and potential problems with colliding, having unsafe changes colliding with changes you've made against the raw database. We've got a rule about onion architecture. I'll just bring that up. So you want to find out more, please go and read the SSW rule. It's pretty much about what it's for, and the key takeaway from onion architecture is use interfaces. Declare all the bits that interact between your code as interfaces and push the actual concrete implementations off to the side, because then those things can be changed out with a different implementation just by changing your dependency injection. And you've seen how useful that can be with changing just this one class from Entity Framework in that earlier demonstration. So the question is, should I use repositories? So the benefits are, it's the way you're supposed to do it with onion architecture, and definitely one of the huge benefits is then your code is database agnostic. How important that is to you is up to you. I mean, some people were very keen on, hey, you can swap your database out with this. I've never done that. I've never written a system in one database. And then, actually I have. I went from Oracle to Postgres once. But I was using nhibernate, so it was possible. So it's a little bit of change. But yeah, in most cases, most systems never change their underlying database. So that's not really a key consideration. But you might say you're thinking of doing microservices. You're moving a piece of information somewhere else. It's no longer in the database. It's in an external service. Being able to swap that out because you've got this quite simple, your defined interface between you and the data, not what Entity Framework gives you as the interface between you and the data, makes these things possible. Where if you've just got a dependency on Entity Framework, you don't have any options to move around. With a repository, you've got much easier mocks and unit testing. I don't know if it's possible to mock the DbContext object, but a repository you can. You can create a mock one that just gives you a collection of objects that would have been what you wanted, and then make tests on that.
You can mock any DbContext.
Ah, can you?
Yes, with Entity Framework 6.
Okay, I've not seen that in Entity Framework 7. It might be possible, but it sounds very difficult to achieve. Is it hard to mock the context?
I tried it, but I didn't like it much.
Okay, yeah. So I think it's, what you really want to test is your business logic. And with the business logic, you want to be given pre-filled objects in a certain state that you can then run your business logic against and make sure it comes out. Obviously, if you have integration tests as well, or things that kind of make sure your kind of persistent state is working, that's all well and good, but the key thing is your business logic. And so I find it much easier to mock a repository than it is to mock underlying DbContext configuration. If you want to move up a level and do things like more solid DDD and aggregate roots, so an aggregate root is, say I've got a order object, and that order object has a whole bunch of order items or line items against it. What you'd never do is query your order object and then go and query for your items. With an aggregate root, you have a repository that says, here's my order. The repository only ever gives you a complete order, so the order with its line items, and you treat that as a single entity, not the individual bits that make up that entity. So aggregate root is, this entity exists only when it's full and hydrated, and it's ready to be used in business logic, not across the little bits and pieces. So it's good for processing and logic, but obviously reporting or database speed, that's not the key consideration here. It's getting that object out, making sure it's whole and right, and running logic against it, and then transforming it back again. If you add repositories on top of Entity Framework, you get a clear place to put your code on top. So it helps your architecture in that anything that's to do with that one particular type, a new way of querying it, a particular filter, I can put it in my repositories and reuse it in lots of places, and that helps keep you away from spaghetti code. Some arguments against putting a whole repository layer on top of Entity Framework is EF is already a kind of a repository and unit of work pattern. So you're kind of just creating this layer that just feeds queries straight through to the next layer. So that can just be messy, and it can get in the way. Is it more work? Well, yeah, you've got to generate this layer, and you're hiding functions behind it, and you've got to kind of build it. But and also, if you generate it, you're still getting generally that one-to-one mapping between your repositories and your underlying tables. You've also got a trade-off between true database agnosticism and flexibility. Do you want to be able to add ad hoc queries? Do you want to run link queries against this database? In which case, you've got to kind of give away the fact that this underlying repository can run link queries. You're not going to swap that out with a service call anytime soon. So you've got this trade-off between being truly agnostic or being flexible enough to just go, and I'm not a query against this database and fire this link query into it. To make some of this stuff easier, we do have a library that will look at your entities and generate repositories for them. So, and these, I would say, these are pretty base level repositories. The thing's just supposed to have like find, do a query, and give me a solid, an enumerable, that kind of thing. And what we generally do is we run that. Typically, I've been most recently doing a pretty close one-to-one mapping between my entities and my repositories. In the future, I'm going to do that less and start moving more towards aggregate routes. But certainly, it gives you a starting point to kind of the base repository that's common to most things, and then all those classes are partial. So we build onto that interface that we get by default, we build in more functions and build out that way. So that has saved us time, and it's available in SSW Data Onion. It's currently available for EF6. We're digging through what we need to do to get it to work in EF7. But there are missing features right now, so it's hard. But we are working through that pain. So our original goal was to just have this awesome system where we build it for EF6 and it worked. And we're thinking, I know my way around RMs now. I know how a Hibernate works as well. And I know I could take this and I could put a Hibernate layer in it and it would still work. So I could swap out my database with Hibernate and have the same repositories work with Oracle and with Postgres. So I thought, well, EF7's coming out soon. I'll just be able to make a few tweaks and it will still work. But right now, there's some missing features that are stopping that happening. But they are on the roadmap, so we'll get there eventually. A final demo I've got, which is just a project using repositories. And I'll keep this really simple. I'm just going to show you what a controller class looks like if you're using repositories. And this is pretty much the simplest basic example I could give you. And this shows you entity framework and dependency injection at work using Artifact here. So I've got a controller, which is a MVC controller. It needs two things to do its work. It needs the unit of work pattern, if in case I want to make changes. And in this case, I've made a VM mapper. So that's a little function that's going to actually build my view model, because I don't want to be streaming out persistent objects that might be lazy loaded out to a JSON engine or out to a view model engine, because that will just potentially accidentally stream out the whole database to the client. So I always put a view model and project into that view model. And anyone that saw me last year will have seen this already. So my view model mapper, what that needs to work is the student repository. So it needs to know how to get students out. So what it then does is it's got a little converter to convert to view model. That runs a view model projection. And the view model projection itself, it's specifically written in a way so that it's an expression that can pass straight through to link. And I've written it in a way that the link to SQL engine under the entity framework won't fall over. We'll post that into an inefficient query. So I've made this reusable projection. I called it a couple of times in order to convert objects from the database through to the view model. So what I've got here is when I'm doing a get, I'm always using a select statement. So I'm not actually getting the entity, I'm getting the view model in this case and passing that through. And when I'm doing a post, then I'm getting the full model. If I wanted to work with the entity at all in read-only mode, I would do, like was said here, as no change tracking. But the key thing is that when I'm actually using it in real life, I've got mappers and units of work. I don't have any concrete references to entity framework or anything to do with my database. It's just separated out clean, and I can change that round as and when I need to. Sorry, wrong place. Okay, so finally to wrap up, I've got some suggestions for your team and suggestions for entity framework team. First of all, I'm going to say that Entity Framework 7 or Core is not an upgrade to Entity Framework 6. At least not yet. I would use it for a new .NET Core project or for a new web project using the new MVC stuff, but I would not consider right now trying to get from Entity Framework 6 to Entity Framework 7. Because there's no clear upgrade path from EF6 to EF Core. So I keep saying 7 and I should be saying Core. But the big takeaway is the underlying fundamental design of Entity Framework Core is a big improvement over Entity Framework 6. You've got dependency injection in there, you've got the ability to swap stuff in, and that's going to be important because the goal is to get people to contribute. The goal is to get teams to come along and add a layer for their database. That won't happen if the thing has too many assumptions that you're working with SQL Server, and that's why we didn't see any non-SQL Server databases for Entity Framework that I know of that actually work. So the goal is that we will get these other databases now, and so on that front, it will compete much better within Hibernate, which has always had multiple databases. But right now, the full implementation of all EF6 code first features is incomplete. There's some missing features that are on the roadmap, and also I'd like to take anything away from this project, if you're considering using Entity Framework, take some time to look at and decide upon your architecture and lifecycle management. Pick one of those and try and stick to it. And there's nothing wrong with using that simple using statement and keeping it simple, and you know that you've got it right, because the other ones are harder. They might save you some time, they might be easier to use, but they're also harder to debug. Finally, read the roadmap. I'll bring that up actually, because that's the key place to see what's going on, what's happening. So here we are with the roadmap. It's got a big list of features that are implemented and a big list of features that are in progress. So in progress are getting the data annotations. Another thing that's missing is in progress is the table per hierarchy inheritance pattern. Hierarchy is something that default databases don't do. I'm sure there's ways of doing it. One particular pattern is table per inheritance. So you have a whole inheritance tree where all the different types have records in one table, and you have a discriminator pattern, this discriminator field that tells you what database, what class that is. I hate this pattern because it means you've got to have a database full of null fields. If it's not of that type, there's fields in that record that have to be null. So it means you're full of nullable fields. It's not a pattern I'd use. I like table per type instead. Documentation's being worked on. They're still working on the reverse engineer from database, that stuff that's coming up. Currently works on Mac and Linux, but they're working on stability. And data stores are still in process, so Postgres and SQL Compact are still being worked on. So that's the complete, in progress, and stuff on the roadmap for 1.0 are here. There's better logging, better support for deployment, and finally the backlog features. So right now, the explicit loading isn't so great, which is not so good because lazy loading isn't so great either. So you kind of need one or the other. Improvements to logging again. There's a few things missing, but the big ones for me are they've got visualize the model here, which I don't really care about, but the one I really care about is the many-to-many relationships without a joint entity and lazy loading.